Steels. Steels, alloys of iron and carbon. It contains other elements silicon, manganese, sulfur, phosphorus, nickel, etc. Specification of steels. First two digits indicate the alloy content. Last two digits indicate the carbon concentration. Classification. Plain carbon steels. Low carbon, medium carbon, high carbon. Alloy steels. Low alloy steels, high alloy steels. Plain carbon steels. Composition. Carbon 1.5%, copper 0.6%, manganese 1.65%, silicon 0.6%. Other names: non-alloy steels, straight carbon steels, carbon steels. Characteristics: moderately priced, sufficient ductile, available in all forms. Applications: mass production products, automobiles and appliances. Ball bearings, structural members, base plates. Classifications: low carbon less than 0.25%, medium carbon 0.25 to 0.60%, high carbon 0.60%. Low carbon steels less than 0.25% carbon, mild steels, relatively soft and weak, cannot be hardened appreciably by heat treatment, good formability and weldability, strengthening of low carbon steels by cold work, outstanding ductility and toughness. Microstructure of low carbon consists of ferrite and pearlite, least expensive to produce. Applications: automobile body components, structural shapes, beams, channel and angle iron sheets that are used in pipelines, buildings, bridges, and tin cans. Medium carbon steels 0.25% to 0.60% carbon, heat treated by austenitizing, quenching, and tempering. Low hardenability. High strength and hardness properties are achieved with the help of heat treatment processes. Applications: railway wheels, railway tracks, gears, crankshafts, machine parts. High carbon steels more than 0.60% carbon, hardest and strongest of the carbon steels, less ductile, more wear resistance, capable of holding a sharp cutting edge. Applications: cutting tools and dies, knives, razors, hacksaw blades, springs, high strength wires, ball bearing, wood cutting and metal cutting tools. Alloy steels: any steels other than carbon steels. Manganese 1.65%, silicon 0.60%, copper 0.60%. A steel is considered to be an alloy steel if a definite amount of other alloying element is required. Alloying elements: chromium, nickel, molybdenum, vanadium, tungsten, cobalt, boron, copper. Alloy steels. Purpose of alloying: to increase its strength, to improve hardness, to improve toughness, to improve resistance to abrasion and wear, to improve machinability, to improve ductility, to enhance grain size control, to achieve better electrical and magnetic properties, to achieve better hardenability. Alloy steels. Classification: low alloy steels 3 to 4% alloying elements. Pearlitic alloy steels. AISI steels. American Iron and Steel Institute. Structural steels or constructional steels contain chromium, nickel, copper, manganese, molybdenum, vanadium, etc. HSLA steels. High strength, low alloy. Microalloyed steels contain Aluminum, nickel, and vanadium will be added. High alloy steels, more than 5% of alloying elements, require different heat treatment than that of the plain carbon steels. Tool and die steels, used for tools and dies. Stainless steels, used for improving corrosion resistant.